Hello everyone. Today I'm going to discuss the concept of limits. Here we have 2 points x1, y1, x2, y2 on the line. So x2 equals x1 plus delta x, y2 equals y1 plus delta y. The line slope m equals y2 minus y1 divided by x2 minus x1 equals delta y divided by delta x. We are very familiar with this definition of a line slope. However, when delta x is infinitesimally close to 0, which means x2 is infinitesimally close to x1, the function delta y divided by delta x should still exist and have the value of m, because we know any points on the line should have the same slope of m. So with the delta x approaches to 0, we introduce the concept limits. With delta x infinitesimally approaches to 0, we can write limit delta x approaches to 0 and the function delta y divided by delta x, which equals limit delta y divided by delta x with x2 approaches to x1, or we can just use x to replace x2. Now let's define the function limit. If a function f(x) has a limit at a point x0, it can be written as a limit function f(x) with x approaches to x0 equals L, which means absolute value f(x) minus L should be close to 0 when x is approaching to x0. However, in this definition, we haven't specified from which side x should approach to x0. It can approach to x0 from right side or from left side. So when x approaches to x0 from left side, we can get left side limit L minus. When the x approaches to x0 from right side, we can get the right side limit L plus. This is a so-called one-sided limit. However, if a function f(x) has a limit at x0, which means left side and right side limits should be the same. So we get the left side limits, right side limits, and the general definition of the limits equals L. Here is the example. If we want to calculate the limit at x0 equals 1 for the function f(x) equals 1 divided by 1 plus x squared, we can use graph method or table method to get the function limit. Here at first we calculate right side limit, which means x approaches to 1 from right side. From the graph, as you can see, when x approaches to 1, we get the function limit 0.5. We can also use a table to calculate the limits. If x approaches to 1 from right side, which means x value is always bigger than x0, although it is infinitesimally close to 1. Correspondingly, the function value f(x) will close to 0.5. So right side limit equals 0.5. Similarly, we can use the graph method and the table method to get left side limits. When x approaches to 1 from left side, the x value should be always less than 1, although it is infinitesimally close to 1. Correspondingly, the function value approaches to 0.5. So we get left side limits 0.5. Now, as you can see, the left side limits and the right side limit both are 0.5. So we can get the function limits at the point x equal 1 equals 0.5. However, as you can see from previous graph, the function f(x) is continuous at the point x equals 1, and the function value at this point equals 0.5, which means the function value equals the function limits at this point. So we can conclude that if a function f(x) is continuous at x0, then the limit at this point should be equal the function value at this point, which can be written as limit f(x) with x approaches to x0 equals the function value at this point. Conversely, we can use this statement to prove whether the function is continuous at a specified point. If a function limits and the function value are the same, then the function is continuous at that point. Here, if we want to calculate the function limit at another point, such as x equals 0, as we know, the function f(x) is continuous at x equals 0, so we can just calculate the function value at x equals 0 to get the function limit at this point, because the function is continuous, which means the function value and the function limits should be the same, equal 1. However, we can't use this substitute method to calculate the function limit at x equals 4 for the function f(x) equals x minus 4 divided by square root x minus 2. Because when we put the x equals 4 into the function, we get the expression 0 divided by 0, which is not defined or not continuous at the point x equals 4. So we can't get the function limit at x equals 4 by using calculating the function value at this point. However, we can still calculate the function limit at x equals 4 by using graph method or table method, or by simplifying this function, which will be discussed in our other videos. Thank you for watching.